In Chapter 2, we're going to look at kinematics in one dimension. So 2.1, we're looking at displacement. And we looked in the last section at displacement versus distance. So a reminder, we have to include a direction. Kinematics is looking at motion, but without a force being applied to that motion. Dynamics is going to include forces on motion when you're studying that. So mechanics, we're going to look at kinematics and dynamics. And mechanics is what's going to encompass much of our physics study this semester. Location. So with location, many of our problems are going to just say things are going to go this many meters north or this many meters south. So you're going to have to basically define that coordinate system. And so come up with, draw your axis, define a 0, 0, and then from your 0 position, you can go that 5 meters east or 7 meters north, whatever the problem encompasses. So you just have to come up with your own axis. So again, just draw that out, pick a spot, define it as your 0, 0, and then work from there. So distance, remember we were looking at how far something moves, from where does it start, and then the total movement that it goes. So in problems, we're going to be using D for distance or displacement, and we'll also use X and Y to simplify that distance or displacement. Distance, scalar, so there won't necessarily be a direction, and we will use meters for distance. Displacement is vector, so you would have to include a direction. It will use the same symbols, D, X, and Y, but also represent, you'll have a delta, which is that triangle symbol, and that means change in. So remember, displacement's looking at just the point of where do we start to where did we stop, that direct line. And often, remember in drawing triangles, it is going to be your hypotenuse. So if you were to start at home in the morning, go to school, maybe go to your friend's house, and then go back to your home, your displacement for the day is going to be 0. Now the direction or the distance that you traveled, the distances you traveled will be, probably pretty great, but your displacement would be 0. So to find displacement, we're going to use the final position minus the initial position of the object that we're looking at. And so that's where that delta, that change in, comes into place. You will see a lot of subscripts used. So for example, we have D sub F and D sub I. So D final and D initial. Your book also uses what looks like a little 0 or naught, but we are going to just use F and I to keep things simple throughout the